Everyone, welcome to yet another interesting video. In this one, we are going to look at this problem which is named permutations. It is on Leetcode and the complexity of this problem is medium. The description of the problem is given an array nums of distinct integers, return all the possible permutations. You can return the answer in any order. Let's look at some of the examples provided. So say if nums is an array with 3 elements 1, 2, 3, the total number of permutations possible between these 3 elements is going to be 3 factorial. So there will be 6 such permutations that can be created from these elements, and each of that permutation is what we have to return as output. So like I said, 6 possible permutations, so 1, 2, 3, 1, 3, 2, 2, 1, 3, and so on and so forth. If the array inputted is having only 2 elements, 0 and 1 in this case, so there are 2 such permutations that can be created among these elements. One is 0, 1, another one is 1, 0. If there is only one element, then there is only one permutation that you can create, and that is the answer that you will provide back. Other constraints for this problem are the nums.length is not going to go above 6. Each of the element is going to be less than 10 and greater than -10, including both the values. All the integers of nums are unique. So after looking at all of these, now how we are going to solve it. So the intuition that I have to solve this program is by taking or adopting backtracking algorithm in the program that I'm going to create, and what it would do. So imagine, like, for this example 1, 2, 3, so you have, say, think of it as like a tree. So 1 is the starting sort of path, and then 2 and 3, and now you would switch 2 and 3 because you have gone through the path which has 1, 2, 3 as the order. So you're going to switch 2 with 3, and then the other possible path is 1, 3, 2. So you will add that to, in this case I'm going to add it to hash set. So that will be another possible permutation that you can create with 1, 2, 3. And then you are going to make 2 as the starting node, and between 1 and 3, one combination is 2, 1, 3, and the other one would be when you switch 1, 3, 1 and 3. So another one would be 3 and 1, 1, 2, 3, 1. And for the last element, 3 would become the first element, and then again same, you would have 3, 1, 2 as one possible solution, and you will add to the hash set, and then you are going to switch 1 and 2, 3, 2, 1. So that will also be added to the hash set, and in total you will have six such possible permutations, and you will return that back as output. And that's how you're going to solve this problem. Now let me write some code, and I will walk you through on how the program will be executed and how it is going to provide the outcome that we are looking to achieve. So like I mentioned, we will have a hash set and instead of creating it here, I will create it as a class variable, and I will explain why we should do that. Because we are going to solve this problem using recursion, and creating a class variable, it makes it easy to keep adding on to it rather than keep sending it in the recursive function. So since we are going to work with the list integer, pardon my typing, list integer, what we have to do is that we have to also put the nums, which is in an integer array, into a list integer, so that we can work on list integer and we can keep adding this nums L to the permutations, and we'll come to that. But for now, So we are creating a list and we are going to populate it with all the values that we have in nums. Okay, and then we are going to call our function where we will be adding the main logic, and we are going to send numsl, and we are also going to send a start pointer, and I will explain when we write the helper function. And once everything is done, we are going to return array list with permutations. All right, so that's the code for the permute function. Now the helper function, where we are going to add the magic code. List integer nums and integer start pointer. So first up, we have to add code for where we will be breaking the recursion, and we will be breaking it when start becomes nums.size, and we are going to add it to permutations.add, and we are going to add new array list integer nums. Okay, so we will do that, and then we're going to return. And the main logic is that we will have an outer loop which will start from the start pointer, and it will go all the way up to the end of the array. And let me declare the variable, and in this what we are going to do is we are going to swap the start element with the first element. At first, you would think that it is not going to do any swap, because when I is 0, start is 0, so there is no swap. But yeah, there is a logic that I will come to in a minute's time. And then we are going to call helper, we are going to call nums, and we are going to increment start by 1, and then we are again going to do collections.swap nums start I. So this is the program. Let me just remove this comment line. Now let's just run it. Arrays. So this works, and this was expected because I did test the code before creating this video. Now the interesting thing that how this thing works, and I have logs for this program, so let me just first copy paste those over here, and then we can look at how it is working. All right, so what I did, at my end, I added print statements before the swap here and after the recursion. So when I is 0, the start is 0, so I is starting at 0, it is trying to do a swap. So there won't be any swapping happens because both the indices are same, 0 and 0, so 1 would remain as 1. And then we are doing a recursion. So recursion with start as start plus 1, which is 0 plus 1. So start becomes 1, our I becomes 1, and we will try to do swap with 1 and 1. There is no change. And then again recursion, Then again we are recursing with start as start plus 1. So start becomes 2, I becomes 2. And again we are trying to do swap of 2 and 2. There won't be any swapping. Now we are recursing with start as 2 plus 1, this particular statement. So start becomes 3. So we come to this statement, we look at, start. Yes, start is equal to the size. Now it is a time for us to add this nums array list into permutations. So we added one permutation into permutations hash set. So 1, 2, 3 is added now, and there is a return statement. So it returns back to the point where we sent 2 plus 1. So it returns back to this particular statement, and then it tries to do the rest of the stuff. So rest of the stuff we'll try to do this swap 2 and 2. There is no swapping that can happen. Then I becomes 3, so it goes back to the previous point, which is this one. And in this one, first thing, it will try to do swap 1 and 1. There is nothing that will happen. Now the loop is at I is equal to 2. So the first swapping, it will try to swap second element with first element. So second element is 3 and this is 2. So the array becomes 1, 3, 2. And then we go again, because there is a recursion, and start has become 2 now. So start has become 2. There is no swapping that can happen, because 2 and 2 both are same indices. We are recursing with start as 3, and then we land up in this condition. This condition matches, permutations get added with another permutation that can happen for the given array 1, 3, 2, and then it comes back and tries to do the swap of 2 and 2. There is nothing that can happen, so it goes back to the point where this point. So it goes back where I was 2 and start was 1. So I and 2 and start was 1. So it switches back between 3 and 2. So it makes it 2 and 3. Now all of that has been done. It goes back to this point, and at this point I is 0, start is 0. There is no swapping. You do swap 0, 0. There won't be any change. But for the next iteration, I becomes 1 and start is at 0. So now there will be a swap after recursion. There will be a swap which is 2, 1, 3, and then you go to I 1 and 1. So, and you will go it till all the array elements. And the intuition that I mentioned to you initially, that first up you're looking at this and you're going to switch between 2 and 3. 2 and 3 becomes 3, 2 here, it gets added, and then you get you make 2 as the first element, you swap between 1 and 3. So you're adding 2, 1, 3 here, and then 2, 3, 1, and so on and so forth. So this is what the intuition for the program is. Now you might be wondering that why we don't see the output in the way I explained in the code. Because one thing that I wanted to talk about before I make that change is that in order to see it in that manner, you would have to use linked hash set, and when you do that, you will get the order the way I explained. So perfect. Yeah, it's a very interesting problem, and we will talk about more backtracking type of problems in the next set of videos. So in terms of space complexity, so we are creating a hash set which is going to create all permutations, and the total number of permutations that we will have is going to be n factorial. So space complexity is n factorial. In terms of time complexity also, it is going to be in that order itself, because what we are doing is that we have an outer loop, and then we are calling the inner loop with a reduced number of n, because we have a start pointer. So the time complexity will also be of the order of O n factorial. Yeah. All right. Let me know if you have any questions, and if you have any suggestions about which type of problems I should talk about in my videos. I would be very happy to accommodate those requests. Thank you.